Hey everyone, it's Dr. Major. I'm so sorry that we were not able to meet in person yesterday, but with the power of technology, we are still able to review the information that we would have discussed yesterday. So, Unit 1 for our class is going to be based off of chapters 1, 2, and 3 from the Cohen textbook. We're not going to go through all of chapters 1, 2, and 3 in this particular presentation, but by the time we have our first test, we will have covered all of the information from chapters 1, 2, and 3. All right, well, let's hop right in. So this is a quote. This is a lyric from a Chance the Rapper song. He says, "And we back, and 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 we back. Na 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 na. This ain't no intro. This is the entree." So I particularly like this lyric because I think it applies for what we're doing here in statistics. So it may be tempting to just kind of take it easy during these first few units because the information is very familiar, but this information is key and it lays the foundation for what we're going to be discussing for the rest of the semester. So, in this class, we're hopping into part of the research process. As you all know, the research process starts with a research problem. And so, as researchers, you may come up with a research problem from reading a journal article, maybe from making some sort of observation about the world around you, etc. But you come up with this idea, this problem that you feel like needs to be solved. So from there, as researchers, you review the literature and evaluate you review the literature and evaluate the literature to see what other people have found about this particular problem. From there, you decide that, okay, there's enough literature out there that says that this is a problem that should be explored, or maybe there isn't a whole lot of research out there, and that's why you continue to move forward with the process. The next step in the research process is to be aware of ethical issues and also cultural issues. So, in research design and analysis, you learned about some of the ethical things that we are concerned about as researchers. So, for example, should you collect this data from pregnant women? What could it do to the mother? What could it do to the child? These are some of the issues that we think about. We think about informed consent. So if I conduct this particular study, how am I going to go about getting the participants' consent to actually do the study? These are just some of the things that we think about. We also need to be aware of cultural issues. So as researchers in America, we might think it's okay to conduct a particular study a particular way, but if we were to go to another country, they might be sensitive about the sorts of questions that we're asking in our study. So these are just some things that we should just be aware of. From there, we state the research question or the hypothesis, and we'll talk about those in a little while. Oftentimes, the research hypothesis is based on theory that other researchers have developed, and it also will be informed by the literature that you reviewed in step 2. From there, you're going to select a research approach. You can select from quantitative, a more qualitative approach, or more of a mixed method approach. In this class, we're mainly going to be focusing on a quantitative approach to research. From there, you need to decide how the variables are going to be measured, which we call operationalization. We're going to spend some time talking about operationalization in this class as well. The next step is to select a population or sample. We'll talk a little bit about that, but you review that information in research design and analysis. From there, you're going to select the data collection method. Are you going to use a questionnaire? Are you going to use an interview approach of some sort? This is where you take time to figure out how you're going to collect this information from your research participants. Are you going to use archival data? That's a method that sometimes we use as well. From there, step 10 is to actually collect the data and code the data. Step 11 is where we will focus on this class, which is analyzing and interpreting the data. So we have all this information from these participants, but now how do we make sense of it in order to answer our research question? Step 12 is to write up the report, and step 13 is to disseminate the report. So it's not enough just to collect this data, find out the answer to your research question or to your research problem, and just to move on with your life. No, you need to spread that information to the research community and, in fact, to the local community as well, because people want to know what we're doing as researchers. They want to know the answers to some of these same questions that we have. As I said, in this class, we're mainly going to be focusing on steps 9 and 10. And even though the steps are listed 1 through 13, the research process is actually a circular process. So you start out with the problem and you end up with writing the report and disseminating the report. But then that oftentimes leads you back to the beginning of the process where you come up with another research problem that you feel like you need to investigate. So let's start our conversation by talking about constructs. So as researchers, we observe things, we observe experiences in the world around us. And we oftentimes want to attach labels to these things that we observed. As researchers, we call these things, these objects that we observe, constructs. So, one definition of a construct is an idea, a concept, or an abstraction that has a multiple reference, which in psychology are known as measurable variables. So, I like this particular picture of our friends over here. Because it looks like they're very happy, right? So as researchers, we might want to say to ourselves, this couple looks very happy. How do I measure happiness? So that's kind of a hard question to ask. We could measure happiness by asking participants how many times they smile a day, right? Or we could measure happiness by giving a happiness questionnaire. We have multiple ways of tapping into this construct of happiness, but we aren't able to fully capture everything that happiness entails in a questionnaire or even in an interview. So some things about constructs are they don't necessarily exist as material entities. So we can't necessarily go over and touch happiness. There's not like a happiness object that you can buy from the store. Some other examples of constructs are well-being, anger, racism. Oftentimes these theories stem from constructs or theoretical frameworks. Now, when it comes to constructs, we have two types of definitions for our constructs. So with our constructs, we have conceptual definitions. So think of our conceptual definitions as like the dictionary type definitions that we use for the constructs. So they're the specific theoretical meaning or abstract dictionary type definition for the construct. So one thing that you may want to do when you go home is look up the definition of happiness, right? So you could go home and find a definition of happiness, and that would be our conceptual definition. Or you could look at a theory of happiness and see how researchers have defined happiness in their theory. The definitions that we're going to focus on more in this class are the operational definitions. And operational definitions refer to defining a concept by studying precisely how it is measured or manipulated in a particular study. So the interesting thing about constructs and our operational definitions is the way that I measure happiness in my study may be slightly different than how you measure happiness in your study. So to kind of bring all this together, the construct is like this large abstract thing that we can't necessarily touch. But as researchers, we attempt to measure constructs. When we attempt to measure constructs, we refer to them as variables. So a variable is an event, category, behavior, or attribute that expresses a construct that has different values depending on how it is studied in how it is used in a particular study. The variables are always derived from the construct, and the variables don't necessarily capture all that the constructs entail. So we go from these large abstract constructs into measurable variables. Essentially, we're going from these very abstract things to these more concrete things. So another definition of a variable is anything that can vary among subjects, events, or objects. So some variables that we tend to study, or some variables from the world around us, are gender, race, academic major. You might be a psychology major, but your roommate might be a math major. So there's going to be a difference there in terms of your academic major. So that varies between the two of you. Height is another variable. I'm about 5'5". My dad is like 6'4". I wish that I was as tall as him, but some things don't always work out the way that we want them to. But that's another example of how the two of us vary along this variable of height. Another variable is weight. People vary in terms of weight. Some people weigh one weight, other people weigh another weight. Another variable is psychological well-being. So how well does a person adapt or adjust to the world around them? What is their well-being like? That can vary from one person to the next. On the one hand, we have variables, but then we also have constants. So constants are these things that don't vary among subjects, events, or objects under study. So the speed of light. The speed of light is always going to be consistent. It will not change. The number of heart chambers that a person has. For people who were born with healthy hearts, there's a certain number of heart chambers that they have. Status after graduation. Once you receive that degree in the mail, you have officially graduated from a university or from an institution. When you all receive your degree in the mail from Howard University, that means that you have fulfilled all of the requirements for graduation and you are now an official alumni of Howard University. Another example of constant is pi. So why don't you take some time to think about some variables and think about some constants, and we'll talk about those when either the next time that we meet or in an activity that I have planned for you all. So we can take variables and we can break them up into two separate groups. So as researchers, we often think about independent variables and dependent variables. So independent variables, these are the variables that we presume is going to cause a change to occur in another variable. It's the causal variable. Think of the independent variable as like the enforcer. When the independent variable is present, it's having an impact or it's having a change on some other variables. I don't know if you all did this when you were younger, but when I was younger, my teacher brought some dominoes to the classroom, and she set the dominoes up around the room, and they were right next to each other, and we pushed the first domino, and that domino led to let me try this again. I'm so sorry. So we set up the dominoes right next to each other, and we pushed the first domino, and that led to all the other dominoes falling down. Think of your independent variable as that first domino that you knock over. That variable is having an impact on all of the other variables. The independent variable is what we call the causal variable because it's causing some change to happen. Now, your independent variable can be either measured or manipulated. We'll talk about that in 1 second. Your dependent variable is the variable that's receiving the change from the independent variable. So a definition is a variable that changes because of another variable. It's the effect or outcome variable. It's the variable that measures the effect of the independent variable. So if on the one hand we have independent variable that's causing some change, the dependent variable is the variable that we measure to determine the impact of the independent variable. The dependent variable can only be measured. Let me just go back for 1 second. So with the independent variables being measured or manipulated, let's talk about that a little bit. So variables that can only be measured are the variables that we can only measure the impact of something. We can't go in and actually physically change or do anything to change that variable. So an example of a variable that can only be measured is height or weight. I can't go in and change someone else's weight. I can only measure that person's weight. I can only measure their height. Now, a manipulated variable is a variable where, as a researcher, I can actually execute some sort of control over the variable. I can control which participants receive the placebo pill and which participants receive the actual drug. That's one example. Another example is I can control the teaching method that I want to use with a group of students. One group of students could receive one teaching method, another group of students could receive another teaching method. So there's a difference between measured and manipulated variables. Your independent variables can be measured or manipulated. Your dependent variables can only be measured. So independent variables, measured or manipulated. Dependent variables can only be measured. So now if we go back to that research process that we talked about in the beginning, we start with our research problem, and then from there we go to our research question. Your research question is an interrogative statement about the relationship among variables. So just like we were talking about in the last slide, we have these variables and we take them and we organize them into an interrogative statement about their relationship. So we might say, is there a relationship between height and weight, right? That could be one research question. It's a statement that is about the relationship among two or between two variables. From our research question, we derive our research hypothesis. Now, if our research question is stated as a question, your research hypothesis is a declarative predictive statement about the research about the relationship among variables. It's made in reference to the research question. So if my question is there a relationship between height and weight? My research hypothesis could be there is a relationship between height and weight. So your research questions can take different forms. One form of a research question could be, what is the effect of X on Y? Is there an effect of X on Y? Is X related to Y? These are just some examples of how you could write your research question. Some other examples: does physical health lead to lower levels of depression? Does sleep influence learning? Are there racial differences in terms of body mass index? Does social media usage impact academic performance? So these are all research questions. They're stated as questions. Your hypotheses need to be stated as predictive statements in response to these research questions. So for this second research question, does sleep influence learning? One research hypothesis could be sleep does influence learning. Alternatively, it could be sleep does not influence learning. So let's practice a little bit more. So let's say our research question is, does social media usage impact academic performance? Now notice that I underlined social media usage and I also underlined academic performance. Social media usage is our independent variable, and our dependent variable is academic performance. So now we're tying in what we talked about before with our independent variable and our dependent variable in our research question. So we said that social media usage is the independent variable because we think that social media usage is going to have some sort of impact. It's going to influence how a person performs in terms of their academics. So this is the causal variable, and this is the variable that we're using to measure the impact of this particular variable. Notice that the research question is written as a question. And I know you already know this, but remember, our questions always have to have a question mark at the end of the statement. Now, our research hypothesis looks very similar to our research question, but we changed things just slightly. We said that social media usage influences academic performance. Again, social media usage is our independent variable. Academic performance is our dependent variable. So let's practice a little bit more. In this question right here, does physical health lead to lower levels of depression? Which variable do you think is the independent variable and which variable do you think is the dependent variable? If you said that physical health is the independent variable, you're correct, and depression is the dependent variable. You got it. What about does sleep influence learning? Sleep is going to be our independent variable. Learning is going to be our dependent variable. We have a few other questions. Does body mass index vary as a result of race? And does social media usage impact academic performance? Those are two other questions that I'm going to let you all practice with, and we'll talk about the answers a little bit later. Now, so we talked about our research questions, we talked about our independent variables, we talked about our dependent variables. And if you remember, I used this term operationalization earlier in my presentation, and we said that operationalization refers to the method used by researchers to measure or manipulate the variables under investigation. So that's all this fancy word means. This fancy word operationalization just refers to how did we measure the variables in this particular study. The way a variable is operationalized can vary from one study to the next. Ideally, different methods for measuring constructs should be related. And if they aren't related, that could tell us something about how they are measured. So with our operationalization, variables can be measured or manipulated. Manipulated variable is a variable under the control of the researcher. A measured variable is just simply making an observation about the size, length, or amount of a variable. Again, for our operationalization purposes, our independent variable can either be measured or manipulated, where a dependent variable can only be measured. So let's talk about some of the skills that we use to measure variables in a study. So you may be familiar with our four scales of measurement. We have nominal, we have ordinal, we have interval, and we have ratio. Let's start with the simplest scale of measurement. So if you have a nominal scale, it means that your data has been classified into different categories. These categories are two things. They're exhaustive, meaning that you've covered all possible options, and they're mutually exclusive in the sense that the data can only fit into one of the categories. So the categories differ by name and not necessarily by quantity. So let's talk about some examples of nominal data. One example is religion. People tend to either be in this religion or another religion, or maybe they even subscribe to a religion that's a hybrid of all the others, but that's still a separate category than being in one specific religion. So a person might be Catholic, they might be Buddhist, they might be Christian. So there are these different religious categories. Type of dog is another example. We have Yorkies, we have Pomeranians, we have Huskies, we have all these different types of dogs or breeds of dogs. Academic major, we have psychology majors, we have English majors, we have dance majors. So these are these different categories where students have to fit into one of the categories. Now, some of you may be saying, well, hold on, Dr. Major, what about double majors? We didn't forget about y'all. That is a separate category by itself. Or what about students who haven't declared a major? That is another category by itself. So therefore, every student that's enrolled at Howard University fits into one of these categories that we consider to be academic majors. Okay? So that's our nominal scale. So going up in terms of level of complexity, we have our ordinal scale. So if our nominal data is organized into categories, with our ordinal scales, we take these categories and we rank them. So it's kind of like that childhood rhyme, first is the worst, second is the best. We won't say what third is, but you all know what I'm talking about. So we take our different categories and we rank them. So we rank them according to some degree to which they possess some measure trait. So how do we go about ranking them? We measure the attribute that we're studying, and then we assign ranks based on how much of the attribute the cases possess. So if we were together in the classroom, I would ask all of us to stand up, and I would ask all of us to tell the rest of the class how tall we are. So one person might be 5'5", another person might be 5'8", another person might be 6'4", etc., etc. So we have all these different heights. So we have 5'8", 5'5", and 6'4". So if I wanted to rank all of you according to your height, the person who's 6'4" would be the tallest, right? So they would get a rank of 1. The person who's 5'8" would be the second tallest, so they would get a rank of 2. The person who's 5'5" would be the shortest, so they would get a rank of 3. So we measure according to some attribute. I measured according to height, and then I assigned ranks based on how much of the attribute each of those 3 people possessed. So some examples of ordinal ranking are military ranking. We also have our university's ratings. So oftentimes we want to know which school is the number 1 in the country, or which school is number 1 for sports, etc., etc. Our grading system is another example of ranking. So some of you may be like, well, wait a minute. A, B, C, D, or F, those are different categories, right? I would say you're absolutely correct. But I would also contend that if a person got an A in the class, that would be a higher rank than a person who got an F in the class. So you see how that works? And another thing about scales of measurement, it also depends on how you're using the data in your particular study. So if you're interested in just creating categories with the grades, then an A, B, C, D, or F, that would just be okay. But let's say you wanted to know based on performance, that's when an A would be considered higher or lower than a C, D, or a B, C, D, or F. Now, so we said the nominal data is organized into categories. Ordinal data, we take into consider ranking. Now, the difference between ordinal data and interval data is the distance between the rankings. So, if we go back to our example where we had all the different heights, we had the person who was like 6'4", we had a person who was like 5'8", we had a person who was 5'5". If you look at the difference between those different heights, it's not necessarily equal, right? So the difference between 6'4" and 5'8" isn't equal to the difference between 5.8 and 5.5. If I got those numbers wrong, please don't be upset with me. We can talk about that the next time we see each other. But the point I'm trying to make is the distance between those different rankings isn't necessarily equal. When it comes to our interval level data, the distance between those scores, between the distance between the scores is equal and consistent throughout the entire distribution. So, how many of you, well, you can't answer this question, but think about the number of times where you've gone to, maybe let's say, the doctor's office, and they asked you to review your experiences, right? And they said review your experience on a scale from 1 to 5. The distance between a 1 and a 2 on that scale is equal to the distance between a 4 and a 5 on that scale. Some other examples of an interval scale, excuse me, let me just go back for 1 second. So that scale that I just gave to you is what we call a Likert scale. And as researchers, we often tend to use Likert scales on different questionnaires. So I'm sure that you all have participated in research studies on campus as well, where you had to rate how much a particular variable applied to you. So maybe you had to rate your satisfaction with your life. So you had to do that on a scale from 1 to 5. We call that a Likert scale. Now, there's a debate in the field about whether or not Likert scale is ordinal or interval, but for our purposes, we're going to consider the Likert scale an interval scale in this class. Some other examples are U.S. shoe size. So the difference between a size 6 and a size 7 is equal to the distance between a size 9 and a size 10 in terms of shoes. Temperature in degrees Fahrenheit is another example. In another class where I taught the same lesson, a student suggested that size in clothes is another example, and she was absolutely right. So the difference between a size 4 and a 6 is equal to the difference in a size 16 and 18. Our last scale of measurement is we'll call ratio. So the distances between the adjacent score are equal and consistent without the distribution. Hey, that sounds just like an interval scale. You're absolutely right. But unlike the interval scale, in a ratio scale, there's an absolute zero, or what we call a true zero. That is, there's a point in which the case does not have a measurable variable. So, with this whole idea of a true zero, it means the complete absence of something. It means something just absolutely doesn't exist. So some examples of ratio variables are weight, salary, the number of years of education. So salary is a good one, because let's say we wanted to know how much a person made last fiscal year. It's very possible for a person to have a salary of 0. They could have made nothing last year. Another example would be if I asked you how many headaches you had yesterday, and you told me you had 0 headaches. That means you had no headaches. There's a complete absence of headaches yesterday. Give me 1 second. Let me plug my laptop in. Thank you for your patience. So these are just some examples of ratio variables. So if we go back to the beginning, we have our nominal scale, where we have the data that's organized into different categories. With our ordinal scale, we have the categories, but these categories are ranked, and the distance between the rankings aren't necessarily equal. With our interval scales, we have these different categories, but the distance between the categories is equal. Another word for that whole idea of equal distance between the categories is equidistance. EQUIDISTANCE. And finally, we have ratio. So ratio is very similar to interval, but the difference is with ratio level data, we have an absolute 0 or a true 0, which means there's a complete absence of whatever it is that we're measuring. So this is a table that describes everything that I just said, but it's just in table form. Some people prefer tables because they present the information in a way that's a little bit easier than other forms. So if we go back to the beginning, we have these constructs that we're measuring, and we measure the constructs using variables, and then we use different scales to measure those variables. So if my construct is happiness, I'm going to be measuring happiness as a variable, and I might use a happiness questionnaire to measure happiness. If the items, which are the statements on my happiness questionnaire, have a Likert scale attached to them, so they ask people how happy they are, not how happy they are, but if they ask people to rate some quality of happiness on a scale from 1 to 5, maybe 1 is completely unhappy and 5 is very happy, then that is considered a Likert scale, and so that would be an interval scale. So again, we're going from a very abstract concept to a more concrete concept. So we have our research questions and our hypothesis, which are broken up into our independent variable and our dependent variable. We operationalize our independent variable, which can be either measured or manipulated, but we only measure our dependent variable. Based on how we measured or manipulated our variables, measured or manipulated our IV, or just measured our DV, that tells us about our scale of measurement. That tells us which scale of measurement we use. And this is important because the scale of measurement dictates which statistical tests we can use with our data. So let's practice. So an educator has invented a new way to teach geometry to high school students. To test this new teaching method, 6 10th graders are randomly assigned to either take a class where the instructor is using the new method or the traditional method. At the end of the semester, all students take the same geometry test. Now, if I were you, one of the first things I would do is dissect this little research problem. So I would go through and I would underline key information. So an educator has invented a new way to teach geometry. So ding, 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 that's really important. Excuse me. To test this new teaching method, 6 10th graders are randomly assigned to either take a class where the instructor is using the new method or the traditional method. Ding, 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 that's also important information. That's why I underlined it. So we have 6 10th graders who are being taught using the new method and 6 10th graders who are being taught using the traditional method, okay? At the end of the semester, all of the students take the same standard geometry test. So just to review, this teacher has come up with a new method for teaching geometry. To test out this new method, she has 6 students that she's going to teach using the new method and 6 students who are going to be taught using the traditional method. At the end of the semester, all 12 students are going to be given the same geometry test to measure their knowledge of geometry. So let's answer these questions. The first question is, what is the research question and hypothesis? The second question is, what is the independent variable? The third question, what is the scale of measurement for the independent variable? The fourth question, what is the dependent variable? And the fifth question, what is the scale of measurement for the dependent variable? So if we go back to this little diagram, we basically just took this diagram and broke it up into question form. So here are some answers to these questions. And just because I have these answers written this way doesn't mean that this is the only way to write these answers. So for the first question, what is the research question and hypothesis? The research question is there a difference in geometry tests based on teaching method? The hypothesis, which I forgot to add, but I'll add to the slides before we put them on Blackboard, is there is a difference in geometry test scores based on teaching method. So the research question, is there a difference in geometry test scores based on teaching method? And the research hypothesis is there is a difference in geometry test scores based on teaching method. The reason why we kind of have this non-specific research hypothesis is the teacher isn't necessarily predicting which method will be better or worse than the other method. For the next question, what is the independent variable? We have the independent variable is teaching method, right? And for the scale of measurement for the independent variable, there are 2 options. The students are either taught using the new method or they're either taught using the old method. So that sounds like 2 different categories for the students to fit in, right? They're either using the new method or the old method. So we consider that a nominal scale. Now, for our dependent variable, the answer is geometry test scores. Why? Because we measured the impact of the teaching method based off of the geometry test scores. We wanted to know how much geometry the students learned. The geometry knowledge in this scenario would be the construct, the variable would be geometry knowledge, and our method for measuring geometry knowledge would be through our geometry tests. So now for the scale of measurement for the dependent variable, let's go through our different scales of measurement to see which one fits the best. So let's start with nominal. So nominal fits for this scenario, right? So a person could either get a 0, 1, 2, 3, 4, all the way up to 100. So we have all these different categories. So that works. So nominal is a possible option. What about ordinal? So some of you could say, yes, technically there is ranking. But if we looked at the rankings, there's an equal distance between the rankings. The distance between a 0 and a 1 is equal to the distance between a 99 and a 100. So that automatically moves us into the interval category. So we're good on the nominal scale, we're good on the interval scale, good on nominal, good on ordinal, good on interval. But what about ratio? So if a person gets a 0 on this geometry test, that means that they didn't get any answers right on this particular test, right? So that means that their score is 0. They got none of the answers right. So therefore, the best option for this particular research scenario is ratio. All the others technically fit, but the best option for this scenario is ratio. All right, well, that's all that I have for you today. I hope that you enjoyed this presentation. I really wish that we could be together, but like I said, we're still figuring some things out with on the administrative side. I apologize for stuttering a little bit. I'm going to work on that for the next time that we do one of these. All right, if you have any questions, we will talk about them the next time that we're together, or you can send me an email. My email address is moniqueamajor@gmail.com. All right, talk to you later.